Hey everybody, welcome to the Tone Church. You're kind of coming into this project sort of already in progress here. What I'm hoping this will become is a very special project. There's a very special little girl out there that has kind of inspired this, and I've been wanting to do this for a long time, and for reasons it just hasn't come to life yet, but I'm hoping this is the one. So if this turns out the way I hope it does, then we'll have a separate video about all that. But in the meantime, what we have here is a Gorilla Double G25 amplifier, which has been gutted. And when I purchased this, it had already been gutted, and somebody was just using this as a like a speaker cabinet. And they, I probably should have taken pictures. They did a marvelous job wiring this up. I'll tell you what.
But
what we're going to do with this is we're going to make a Fender Blackface Champ clone that's even better than a Fender Blackface Champ clone, because it will be completely, well, mostly point-to-point wired. We'll not be using an eyelet board or a turret board or anything. We're going tonepriest full bore on this one. Point-to-point. This is not the Gorilla speaker. This is a Weber Alnico Signature 8. And these transformers I'm using, I'm going to be recycling the transformers from the last Champ build I did. These are out of the current production Fender Champion 600 amplifiers. These should be fine. So they test fine. There's continuity in all the windings. So yeah, let's not put good transformers to waste. Let's stick them in here and we'll build this sucker up, and it should be pretty sweet. So what I've done so far is, this had already been gutted out. Yesterday I tore all the Tolex off of this cabinet because we're going to rewrap it. It's going to be pretty rad.
If you let drugs steal the magic from your dreams, you'll soon have nothing but nightmares. Drugs and dreams, they don't mix.
And so what I'm doing right now is I have some aluminum from an old traffic sign kicking around. I'm going to cut some new face plates, or face plate and butt plate, whatever you want to call that. We need to cut the holes for the transformers, which I've kind of marked out for the power transformer, and holes for the tube sockets. So all of my favorite stuff. But once I get that done, it should be, what do they say, fast sailing? Is that a term? Is that a thing? I don't know what it is. But yeah, so if all that sounds interesting to you, hang tight. Here we go. All right, glad that's over. I had to use this thing because that's what we have to use. That could very easily have ended in disaster or injury or both. But fortunately for me, and more importantly the pieces, they came out unscathed. Nice. Oh yeah, got this guy cut out too. You see that? Yeah, see that? Yeah, that's where the transformer will go. All right, moving on. All right, we cut the hole for the power transformer. It's a lay-down style, so we got to cut a big square hole in here, and it fits, so that's good. So now what we're going to do is we're going to take our Dremel style tool, and we're going to break the edges. Don't want any sharp edges here, and we're also doing that on the edges of our face plate and back plate. And yeah, that's what we're doing. All right, so I'm laying this out. Just want to make sure everything's going to fit. Everything that needs to fit will fit before I start drilling holes and stuff. Here's what the original looks like. Can we get all that? Yeah, there you go. So yeah, there should be plenty of room for everything that needs to be there. And I think I'm going to mount the front and back faces here before I install the transformers. It'll be a lot easier to do all the drilling and mounting with the transformers not on there. So yeah, I think I'm going to mount these with probably 6 screws, either 4 or 6. Probably should do 6 on each side. And then we'll drill some holes and mount some stuff. All right, this is where things can get a little bit tricky here. So I cut the holes for the mounting bolts, screws, whatever, to mount the faceplate to the chassis. And now I have the chassis installed with the screws here. Now I want this thing centered, obviously left to right, but also I want to make sure I leave a little bit of a gap, because once the Tolex is on here, you know, it's going to need a little bit more space, or else it won't fit, and that would be unfortunate. So I'm centering this guy up here. I'm going to grab a tool, grab a this guy here, a little awl, mark out where the holes need to go, drill those out, and bada bing, bada boom.
Come in.
All right, we got all our holes cut. Get some schmeg here. That's just, there's a plastic coating. I can't see it. Plastic coating on the back of the street sign we used here. So that's all that is. But we did use our Dremel style tool to make sure we break all the edges, because we want the, we're going to use tooth washers behind all these components, or in front of, whatever. We're going to use tooth washers because we want a nice secure connection. And we want to make sure there's no burrs.
Hey, either one of you guys know about engines? Oh, of course you do. That's why they call you an engineer, right?
And we want a nice flat surface for those tooth washers to really grab into. But yeah, she's coming along. I'll be happy when all the drilling and grinding will be over and we can start soldering. But that should be pretty soon.
Satisfied? Was that specific enough for you?
Okay, we're moving right along here at a rapid pace. We got the power transformer installed, got all that junk installed. Still need to put the power cord somewhere and the fuse holder. And the, nope, no output jack. We'll probably just hardwire it. So now we're going to start thinking about the guts here. And as I said before, we're going to make a point-to-point build. But one thing I don't like doing point-to-point is the filter caps. You know, I don't want this big, bulky, heavy thing that's going to be flopping around, going from high voltage to a tube socket. So I like to use terminal strips, or tag strips, whatever you call them. And we'll build a power supply probably right about there. And then that will determine where I mount the, well, I'll use that, you know, kind of as a guideline to determine where we're going to put our two tubes. Another thing we need to do is, speaking of two tubes, this does not have a 5-volt winding, so we're going to build a full wave bridge rectifier with diodes. So we're going to have a spot for that, spot for the power supply, and then our two tubes. We have a 12AX7 and a 6V6, and we're going to jam all that crap into here. Can it be done? I think it can. All right, I think we can put the heavy machinery away. There's the power switch here. You can see that I reused the quick connects. I don't know if I'm in love with that idea. I may end up hard soldering those to the switch. But we'll see. They seem all right. Get everything all hooked up. Here is our full wave bridge rectifier. Can you see that? Yeah, it's kind of hard to see. But not the prettiest thing in the world. Could have done better, but we didn't. We have our equipment grounding conductor. Another little, what are you going to do? 3's enough. 3's company. 3 bolts holding the power transformer down. Got our indicator lamp. Got to hook up some heater wires there. That's where these guys will go, and then we'll run a twisted pair to the heaters for the other tubes. Got our pots there, our jacks. We've got one of everything, just like Noah. So we can put the heavy equipment away, and we can start building the circuit. Fun stuff. To save space on the horizontal plane here, We've gone vertical with these Christmas tree terminal strips. And so we're going to have our 3 filter capacitors here. And this side's going to be for the grounds. And right here, they're going to ground through right here, this connection right here where the base is. And we have a screw and a lock nut there. And before we fasten that down, we took the Dremel tool and, got some nice fresh metal there. And we may even go back and, just hit it with a little bit of solder just to seal up the connection, tighten it up. And to get each of these rows to be continuous with the chassis, we took a piece of copper bus wire and just sewed it through the circular parts. So they got little circles in the middle there. Sewed it through like we're stitching up a scar.
Check it out.
And soldered that up, and I think that'll work nicely. Moving along here, I did decide to get rid of those quick connects. Those are, those are bogus. I'm gonna make a point-to-point amp and have quick connects now. We ain't going that route. Got the heater wires over here all connected to the indicator lamp. And we're traveling over here, heating up our tubes. Got the power supply all sorted out for the most part. She's coming along pretty nice. She should be a pretty good little amp. All right, back at it. All right, one change I am making is I'm adding a 470 ohm screen resistor and a 1.5K grid stopper. And as we see on the schematic, the screen resistor is right here between this filter cap and the screen. The resistor itself, the wires go on to pin 6. And then the resistor is jumped over to pin 4. Pin 6 is not used on a 6v6. And right here, we're going, after this coupling cap, it's going to pin 1, which is not used on glass envelope 6v6s. And then the 1.5K is going over to pin 5. And those help with oscillations and keep the tube from getting all unruly. And I generally do that on the amps that I build. But yeah, that's where we're at. I'm going to call it quits for today. Been working on this all day, so hopefully we'll pick it up tomorrow. Maybe even finish it. Who knows? Stay tuned for that.
Day 2.
All right, we are back at it. It's the next day, and I've been working all morning, and I think she's all wired up. She doesn't look too bad, I don't think. Building this thing just kind of not really using a layout or a plan, just using the old tonepriest brain.
That brain that you gave me, was it Hans Delbrooks? No. Good.
And I fixed that. Didn't like those disconnects. Forgot to add a virtual center tap. I would have added it over here at the termination, but I forgot to do it, so I just tacked them in there and used a little thingy here on the leg of the transformer. That'll be fine. That's nothing to worry about. It'll be fine. Have not added the bypass capacitor to the power tube cathode bias resistor yet. If this is the right resistor for the bias to be correct, then we'll add that in after we check all that. But there you go. So now it's time to hook her up to the current limiter on the Variac, dial her up and do all the tests, check voltages, add tubes, do some more testing of voltages, and make sure she's not going to explode catastrophically, and maybe we'll hook up a guitar. Fingers crossed. All right, stay tuned for that. Don't want to miss it. So I went to the bathroom, and that's where, most of my best thinking happens. And it occurred to me I forgot to add the 27K negative feedback resistor. So this basically has no negative feedback or two total. I don't know. So, what to do? I'm all out of lugs for it. I gotta mount something somewhere. So I'm thinking maybe we'll add a switch to the back, or maybe a pot. We can either have adjustable or switchable negative feedback. So not quite ready to inject electrons yet, but almost there. How many other things did I forget to do? All right, I've decided to add adjustable negative feedback. And obviously I'm going to resolder this resistor, but that's a 100 ohm resistor. It will come in off of the 4 ohm tap here, and then goes through here, and then from the center lug, it'll go into the tail resistor on the second triode of the 12AX7. And that'll allow us to adjust between 100 ohms and 10, well, technically 10.1, if everything was in a perfect world, of resistance. So we can have a lot of negative feedback, or we can have not much negative feedback. Will it work? Will it be awesome? I think it will be. But y'all can take bets amongst yourself. All right, let's do that. Here's the hole. Gonna make it bigger.
That's what she said?
I changed my mind on the adjustable negative feedback. We just have an on-off. I didn't know if 100 ohms of resistance was going to allow too much negative feedback to go through, and how that'll affect everything. I just didn't feel like futzing with values and blah, blah, blah. Didn't have a 2.7K in stock, so we're using a 2.2. So whatever. We'll call it a circuit improvement. Oh, how'd that happen? Turning blue. It's Smurfalicious. All right, let's power up. One other thing, these freaking witch hat knobs are just junk. If they don't have metal inserts, the threads always strip out, no matter what vendor I buy them from. Just absolute junk. So we went with chicken heads, because these have the metal inserts. But who doesn't like chicken head knobs better than these freaking whatever? Adapt, overcome. All right, time to inject some electrons into this beast. You can't see it, it's off camera. I got a bench speaker hooked up to it. We don't have the tubes installed, and I've already preliminarily did a little bit of this. Started from 0. I got it up to 40 volts coming off the variac, and we're connected through the current limiter, just in case this thing goes haywire. But now that I know it's not going to blow up in my face, I'll show you what's going on here. Okay, connected to a speaker, no tubes installed. We would start at 0 volts coming from the variac. And we want to check our AC voltage going into the bridge rectifier. And we got nothing. Because that's not where it's going into the bridge rectifier. Okay, there we go. We're getting AC voltage in. Now we switch over to DC voltage, and we go out to the end of the bridge rectifier. That is your B+, which is the wire that goes into the first filter cap. And we're in DC voltage now. Check that. So we had 50 AC in, and we're getting 137.6 DC out. So we're definitely frying our rectum. Put it back on AC. See if there's any AC coming out of the back of the bridge rectifier. And there isn't. So perfect. Our rectum has fully been fried. Go back to DC. And we want to test the first node of our filter caps. And that's the one all the way at the bottom of this tower of power here.
How you feel, y'all? We came to play.
Get 138. And it goes through a 1K resistor to this guy here. 137.8. And then it goes through a 10K resistor to this guy over here. 137.6. It doesn't seem like a whole lot of voltage drop through a 10K resistor, but I mean, I believe it's wired correctly, so Oh, wait a minute. Hold on. No, that's wired right. Is what it is. We're going to go with that. So that all looks good. Let's make sure our heaters are heating. We're going to go back to AC. And yep, they're heating. And the final thing we want to do is make sure we're not getting any AC voltage on the backside of our coupling capacitors. And I'm going to have to look at the schematic and search through here where we want to test. So I'm going to put you on pause for 1 second. But so far, so good. All right, I just noticed something. I missed a connection on pin 3 of our treble, not our, you can't have this, this is mine, of my treble pot has not been soldered, so oops, hang tight. One thing we want to test here, I just turned the power off on the Variac. We're going to turn our multimeter onto DC voltage, and we want to see if the filter caps drain by themselves or if we need to break out the tool to drain them. We're going to do that anyway, but it's good to know. All right, it does not look like we still have 125 volts on the filter cap. So it is supremely important we break out our, can you see that? I hope you can see that, our discharge tool here, which is a 5 watt 470 ohm resistor. So we're going to connect this to the chassis to make it ground, and we're going to go ahead and discharge our filter capacitor. So we'll do it like show, and we can watch it discharge. Now we test it. Now we got 0.6. It'll climb up a little bit. They take like a deep breath and give out one last gas, but... And are all these connected together? Yep. So if you drain one, you drain them all. Yep. So now we're back up to like 2 volts, so we'll do it a little bit more. But good to know. All right, let me get that solder connection in. All right, we got that connection all soldered up. Let me get Mr. Pointer here. Can you see this? Oh, you can't see shit. What's going on here? Okay, so we want to make sure our coupling capacitors are doing their job in coupling. So we have high voltage, B plus voltage going through here to the plate, and then it's also trying to go over here. So our tone stack coupling capacitors, we want to check on the opposite side to make sure no high DC voltage is getting through. So this is our treble pot right here and a bass pot right here. So we're going to want to check on the back of these 3 coupling capacitors. So we're going to check for DC voltage here, here, and here, which is on the treble pot pin 3 and pin 1, on the bass pot pin 2 and pin 1. And then on the other triode of the 12AX7, coming off the plate, again, we go up here, tries to go this way. We want to check on the back half of this 0.02 and make sure we're not getting high B plus voltage over here into the grid of the power tube. So let's do that. And we'll power this sucker up. And of course, when we work on high voltage electronics, we like to do it alone, so the tone nom can come home to a corpse. Blah, 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 blah. What am I looking for? Mr. Multimeter. Where can I put you so you can see it? Can you see that? Yeah, there you go. So we're checking for DC. Put Mr. Multimeter in DC mode. Give him a clamp onto the old chassis. Check for continuity. Make sure we have a good connection over here, which we do. All right, DC. So what did I say? Pin 3 and pin 1 on the treble pot. So this is treble pot. First things first, let's make sure. Might help if I turn the amp on. There we go. There we go. I'm trying to do this without shorting the whole thing. Oh man, I gotta watch my language. This is supposed to be a nice video. 0. Perfect. And then pin 1. 0. Excellent. Then on the bass pot, pin 2 and pin 1. So I can't see what I'm doing here. I'm for sure going to get electrocuted. Sugar. All right. Here we go. Nothing. Pin 2. Nothing. Beautiful. All right. So I think we're ready to stick some tubes in here and see what happens. So what I'm going to do now is stick some tubes in here and we'll see what happens. Okay, I dialed it up to 90 volts from the wall and hooked up a guitar and nothing happened. But I think the 12AX7 I got in there is toast. I just grabbed the closest one that was available, which was an unknown one, vintage one that it came with a Hammond AO29 chassis I bought. So it doesn't look like the heaters are heating. So I took the time to dig through the pile, and we have a modern issue, basically unused Mullard 12AX7. And the power tube I'm using is a modern Tunksol, also basically brand new. So we'll take that unknown quantity out of the formula, out of the equation, and see what happens. But I have a feeling I either miswired something or something has not been connected. You know, pretty much par for the course. It'll be something stupid. Nope, still got nothing. I missed a solder connection right there on 12AX7, one of the cathode grounds. Actually, is that... Oh, that's not even grounded. Oh, where's your
Crikey dingo
problem? Let me try that. Let's ground the cathode to the vacuum tube and see if that helps. Alrighty, let's try this again. Pardon me. What do you got, like 90 volts off the Variac? Well, what do you know? Nice. The volume cranked. Treble works. Bass works. Volume works. Cool. All right. Getting those swishies on the volume knob of the guitar, so that's a good sign. Sorry about the squeaking chair. Do all my building on a drum throne because why wouldn't you? Wow, excellent. Cathodes, who knew? Important. All right, I guess now we dial her up all the way and see what we get. Yeah, cool. I'm pretty happy about this. I think I mentioned before, these transformers came from a modern Fender Champion 600 that my buddy had, and he said, hey, this thing doesn't work anymore. Can you take a look at it? And I basically rebuilt that thing. You can look in my video history for that whole thing. But we replaced those transformers that came in the Champion with some classic tone transformers, so I just had these kicking around. But I had no idea whether or not the problem with the amplifier were these transformers. I didn't know if these were going to be good, but it appears they are good. So happy days are here again. All right, I'm going to crank her up and I'll check in after that. Yeah. All right, got her all cranked up. She seems to be running nicely. Nothing crazy going on. Super quiet, you know. The only time it makes noise is when I've got single coil pickups sitting right next to my computer, and that, whatever. But other than that, yeah, she's super quiet, because the tonepriest rocks. Check the bias, out of focus. That's the bottom line right there, 13.7. According to the RCA Bible, if we can get this frickin' thing in focus here. Watts. Right there. 14 max, we're at 13.7 for a cathode biased amplifier. We frickin' nailed it. So what I'm going to do now is solder on the bypass capacitor for the power tube cathode bias resistor, and then we'll plug her into the cabinet with the nice Weber speaker and see what she really sounds like. Output transformer is looking for a 4 ohm impedance speaker. This is like measuring 6 ohms, measured DC resistance. So, it should even kick some more ass once I get that all hooked up. So, yeah, let's do that. Oh, for the love of God. Somewhere around here, there's a 20 microfarad Sprague capacitor. I can't find it. That'll pop up sooner or later. I got another one in stock. It's going to go right there. Oh, shit, we're upside down. Anyway, get in focus. There we go. It's probably for the best that I couldn't find the Sprague. The Sprague is a 25 microfarad at 25 volts, rated at 85C. I'm going to go ahead and use the mod. 25 microfarad at 50 volts, and it's rated at 105 degrees C. So it's a little more robust, at least on paper. And, sitting right next to the big giant resistor here, next to a tube, and yeah, this will be better. Not as pretty. Doesn't have the mojo as the Sprague, but it is what it is. All right, let's get her in there. Found it. Yeah, you can't see that I screwed the whole frickin' scene up. God. All right. Working on sticking this back in the cabinet here, and since we're in the tone church, we can't use Martin tubes. That will just not do. So I dug this bad boy out of the pile. Oh yeah, look at that. Nice, and that should go good with this Sylvania that came from the AO29 I bought recently. Hopefully it works. Probably works better with the cathode connected, grounded. Yeah, so let's pop those in. We'll pop this in the cabinet and take it for a test drive. Don't laugh at me. Sounds just like the record.
You fucking idiot.
Boom. Definitely has new speaker disease. It's got that ice picky. Needs to chill out a little bit, but a little back on the trebly there. Oh yeah. Let's put it into type O negative feedback mode.
I'm missing a little song for you now, so listen up.
And it's this other guy who makes movies. He made that movie of the horrible.
Yes, I totally
Fuck
agree.
that motherfucker.
Boy.
All right, there you have it. I'm going to call it quits now while I'm ahead, and I'm not going to embarrass myself anymore with my horrible guitar playing. I just can't think of anything to play today. But it's just crappy, cell phone camera microphones anyway. So we'll mic her up. We'll put her on the Rumble Dyno. We'll do a demo, hopefully, with this bad boy. Definitely has new speaker disease. It's just really ice picky. So we got to break this sucker in. So we'll probably, in the meantime, before we record any demos, crank it up to 10 and just play AC/DC for 3.5 days straight. What we also need to do, I mean, if this was up to me and this was my, amplifier, I was going to keep this amplifier, I'd just leave it like this, right? Know what I'm saying? But I'll get a nice handle for it. That'll look much better. Oh yeah, and then we got this too. We have some nice ruby red colored dinosaur skin Tolex for this bad boy. That will look pretty sweet, I think. I know somebody who will like it. All right, thanks for coming. Thanks for watching. Hope you learned something. I sure as hell did. Yeah, until next time. Rock on, dudes and dudettes.
Done.